Okay, we're going to do some extending off of some of the ideas that we worked with yesterday. So you're going to need this paper that you were working on with Prisms, this packet that you also had. If you have some popcorn and want to try the experiment, you could get that. You might need a little bit of tape. And then I've got a glass container that I'm going to do some of my measuring in, okay? So a couple of those things, okay? So our goal today is to compare prisms with different bases, okay? So we're going to look at, we kind of talked about naming them yesterday, a triangular prism, a rectangular prism, a pentagonal prism, and a hexagonal prism. We're also going to look at a cylinder. We're going to compare their volumes, okay? But they're all going to be made out of a single sheet of just regular paper, okay? So like printer paper. So the first thing I want you to do is to go ahead and take off these two sheets. You're going to just kind of put those aside. We'll need those later. And then behind it, you're going to have to kind of unstaple them. You should have 4 sheets of paper with lines on it, and then you actually need 1 blank sheet, okay? So what you're going to do first is you're going to assemble the different prisms. So you notice the lines that it has here. I want you to go ahead and fold on the lines. I'm going to fold on the lines. Put this aside for a second. Okay. And then you're going to build your prism by taping together the edges. So I'm going to just kind of put those like this. Okay, and line them up. And take a piece of tape to assemble it. Okay, so put the edges together and then tape them. Don't overlap it, okay? So I want them to all have the same perimeter around. Okay, so you're a triangular prism, and then you're going to do the same thing. Make your square prism. Fold along the edges. Okay, or sorry, along the lines. Okay, and then you're going to put it together by using tape. Okay, so your square prism, it's actually a square on the bottom. Square prism. And then you're going to do your pentagonal. Pentagonal is probably the way you should say it. So again, trying to fold on those lines. Pushing these together. Okay, got that prism. And the shapes on the top are all what are called regular polygons. So I'm just kind of chit-chatting as I'm folding. They have the same length on each side. Okay. And the angles are actually the same. Hexagon. Okay, so I'm just going to make a hexagon at the end. I'm not going to make money as a YouTube star. Okay. And then with the cylinder, make sure it's got the same height. So make sure you kind of roll it long ways, okay? And again, try and just put the edges together. Okay, don't overlap. Okay. Okay, remember we talked about yesterday, a cylinder is not considered a prism. It does not have flat sides, okay? But it's got a lot of similar features to a prism, so we're going to do something with that too. Okay, so then you have your 5 different prisms. They all have the same height. The distance around on all of them, the perimeter, okay, is the same. They're actually just made out of a single sheet of paper. All right, so I want you to then look at these 2 questions at the bottom of your paper, okay? So if these are the shapes, the first question is how do you think the volumes will compare? So that's number 3. So if I look at the volume of these 5 different 3-dimensional shapes, how do you think their volumes will compare? Okay, do you think they're all going to be the same, different? Do you think they're going to be different? Do you think one is going to have more volume than the other? Okay, and then how do you think the surface areas compare? Okay, and we're going to assume that I could put a top and a bottom on each of the prisms. Okay, so kind of the top and bottoms from this paper from the other day, or at least one end, okay, one of the bases. But how would the surface area, so the amount of paper that it takes to make these, once I include the top and bottom, how would you think those are going to compare? Okay. All right, so if you look at the back, it says using paper, build them. Okay, so we did. And then we're going to think about trying to find the volume of each of these shapes. So how do you think I could maybe use this popcorn to help me at least compare their volumes, Okay, so what I'm going to do is I'm going to start with my triangular prism first. I'm going to go ahead and just put this in this glass container, okay? And then I am going to make some comparisons about how much popcorn these hold. So I'm going to go ahead and fill it with popcorn, kind of pull it out and see how high the popcorn goes. Okay, and if they're all the same, which is what some of you guys might have thought, the amount that it goes up to should not change. Okay, I'm going to make sure that I'm not bending, that it's staying a triangle. Okay, so it's not bending out at all. I'm just going to try and fill it easily to the top. Okay. All right, and if you don't have popcorn and want to just still try this at home, I mean, you maybe have some other, like if you've got something, shoot, I got 2 pieces in there. Okay, well, those 2 pieces, I'll just not include 2 more. Okay, so where I thought I had a box of Kix cereal, I thought maybe I could use that. Okay, and then I'm just going to kind of slide this up. Okay, and just sort of level it out a little bit. Okay, and I'm going to take a look at about how much. I'm going to just take a marker on my jar and see about how high it went and make a mark there. Okay, so I'm thinking it went about, it's made a mark, I don't know if you can see it yet, right here. Okay, and dump that back in. I'm going to compare that to my square prism. Okay, so I'm just kind of repeat. Now you can see the red line a little bit better. I'm going to go ahead and fill it and see if the volume is the same. Oops. Or smaller or larger than it was for my triangular prism. Okay. Oh, goodness. I can mess here. Okay, so I'm just kind of filling it loosely, kind of to the top. That's probably good. Okay, so I'm going to go ahead and just pull it out like I did last time, slide it up. Okay, and let's see, how does that seem to compare to my triangular prism? Okay, it was a little bit higher. Okay, so I actually had a little bit more volume than I did for my triangular prism. Okay. All right, I'm going to do the same thing. I'm going to try my pentagon in here. Oops.
With ground beef, you said?
No. Sorry, I'm making a video right now. I was just going to make this spaghetti sauce.
Right.
Okay, so now I've got my pentagonal prism. I'm going to go ahead and I've got it pretty much filled to the top. Okay. All right, so I'm going to go ahead and just pull that one up and see how that volume seems to compare. Okay. All right, it looks like I got slightly higher with that one too. Okay. This one filled a little bit more than my previous one. Okay. All right, let's try it with the hexagonal prism. Same thing. Now, is this the same thing that's happening for you? Did you get slightly more when you did it? I'm starting to wonder how scientific this whole popcorn method, though, is. If there's a better way that you're thinking you could find the volume besides just filling with popcorn, huh? Okay. Top. Too much. Okay, so I'm going to go ahead and slide out this one. Okay. And look. Okay, so again, I'm just going to kind of make a mark on my jar. It does look like I've got a little bit higher again this time. Okay. And seems like if things keep going the same method, this might give me the most, but let's see what happens. I'm going to hold this so it stays as circular as possible, okay? Okay. More. Up. Okay. Done. All right. Okay. Now, did the same thing happen for you? That one actually gave me the most. So if I look at that one, I don't know if you can see the red lines on here, but I actually had the most volume with that cylinder. So I think even if I put the paper in here, maybe you can see the different lines then. It should open up. Okay, so the one with the least amount was my triangular prism. Okay, so with the triangle on the end. And then I had my square prism was next. And then for me, my next one was the pentagonal prism. And then my hexagonal prism. And then it seemed like the cylinder actually held the most popcorn. Okay. So when I tried that with popcorn, that's how my volumes compared. Now, I don't know how scientific filling this with popcorn, is that really a great idea? Let's go ahead and take a look at this paper from yesterday, and maybe we could find a better way of actually calculating the volume besides just playing around with popcorn, okay?
Hey, boss. What are you doing?
I'm making a cake for the Geometry Club's big party.
That's a cool shape.
It will look amazing when I'm finished, but first I need to figure out how much batter I will need to make a cake that will fill up this container. But its base isn't a square like the cake is. It's a right triangle.
I've got an idea.
Yeah? Okay, go ahead. Why did you cut my cake up into these tiny cubes?
Watch. I just need to make one layer of cake on the bottom here.
But what do you do about the corners?
Just cut a few cubes in half on the diagonal, and these will fit just perfectly.
So it seems like we figured out with popcorn that this one had the least amount of volume and this one had the most. But I don't know if popcorn was really the best way to measure this accurately. I do have these little cubes. Are these little cubic centimeters? I know you've got one in your, should be in your container of stuff or your envelope of stuff. I wonder if I could measure each of these with cubic centimeters instead. Okay, so I remember yesterday you were supposed to find the area of this. Okay, I could put this on top and I could start. No, those don't exactly fit in there so well, do they? So I could kind of think about that layering that idea, but how many of these cubes could I fit in this bottom triangular layer? I mean, I could try and place them on there, but some of them. Oh, wait, didn't you have to find the area of this thing yesterday? When you found the area of that, what did that end up being when you had that triangular prism? I mean, when I did it, it ended up being about 38. Okay, was the area of this triangle. So 38 of these little squares could fit on here. Can I use that to help me figure out the volume of this? So if I could fit 38 cubes in one layer on the bottom, I wonder if I could somehow use that to figure out how many cubes would fit in this whole thing. So I don't even know if I could dump this in here. And plus, it's going to be the same thing with the popcorn problem, that they'll have little air holes and stuff. Okay, so how could I use that? The fact that there's 38 cubes would fit on the bottom to be thinking about how much volume this thing has. Okay, did you think, well, maybe I could just look at how many layers high this thing is? Maybe try and put your paper along this side of this thing to count how many cubes high this would be. Can you just kind of count this? Looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So it looks like I could have figured out the volume by thinking, all right, well, I know in one layer I could fit 38 cubes, and then I could do 22 layers high of 38 cubes. Would that be a better way of calculating the volume? Okay, so why don't you try and redo this one, and actually figure out how many cubic centimeters would fit in this. Okay, now again, these are cubic centimeters, but they're not going to fit perfectly. I have to kind of think about how I could cut those a little bit better. Okay, all right, so go ahead and calculate the volume from this one, and I'll let you know in the Ed puzzle if you got the right answer. Okay, all right, so how about this one? Could I calculate the volume of this one then? All right, well, how many cubes could fit in the bottom layer of this? And again, this one actually fits kind of nicely because I could take these cubes, and how many could I fit on the bottom? Well, I could fit 7 across and 7 down. So you should have figured out yesterday that for this one, okay, so the area of this one was actually 49, okay, is how many squares would fit along here. And then think still how many layers of 49 am I going to have to fill this thing, okay? So go ahead and calculate that volume, and I'll let you know in the Ed puzzle if you were on that, okay? All right, so then the next one I want you to take a look at is your pentagonal prism. So kind of same thing. You know, you were supposed to try and calculate the area, okay, of this pentagon yesterday. Okay, you probably did some counting, maybe thought about dividing up, but it should have an area of about 54. Okay, so that's how many of these cubes could have fit in just one layer of this. So if I could fit 54 in one layer, and I've got 22 layers high, can you calculate now the volume of this using cubic centimeters instead of popcorn? Okay, so let's do the same thing thinking about these two. So now I've got my hexagon, okay? So in this one, actually, if you calculated the area of the hexagon, okay, it should have been about 57 approximately, okay? So that's how many cubes could fit along or inside this. So not really that much more than what I had for my pentagon. So again, and then how many layers high? I've got 22 high. So see if you can calculate the volume for that one, okay? All right, and then how about this one? Did you guys think instead of trying to count Then you could maybe just use a formula here and say, oh, well, about how far is this? That's my radius. I'm going to take my radius squared, multiply by pi, and then figure out what was in here. You should have ended up getting it about 63. Okay, about 63 would be the area of this circle. Okay, so if I could fit 63 of these cubes in just one layer, and I've got 22 layers high, I want you to go ahead and see if you can figure out the volume of the cylinder. Okay. All right, so go ahead and fill in then on this sheet what you got for your triangular prism volume, your square prism volume, pentagonal prism volume, the hexagonal prism volume, and the volume of your cylinder. Okay,